So let's go on to the things that we have to consider when designing the pattern. So let's say we've been given this final product that we want to make. Something like this that looks like that. Maybe there's a little hole there. I don't know. But the point is, now I have to design the pattern for it. This is the final product. This isn't the exact thing that we're going to have the pattern be, because as you saw from the video, the previous one, if you haven't seen the intro one, it's really good at illustrating how these little concepts actually work together. But we're going to have to be removing this mold. Sometimes it is easier if it's slightly slanted when you remove something. As well, not only are we considering how easy it is for removal, we're also considering the fact that it's going to be at very, very high heat, a lot of intense stuff happening. So we want to minimize cracking or propagation of cracks like that, or hot spots that could damage the integrity of the metal consistency, or it being, like when you're baking brownies and the sides are a bit more crispy than the middle, stuff like that. Just in general, we're just going to do a bunch of little things to make sure that it's consistent, that it's easy to remove, and that it's just good structurally overall. Okay, so let's go to the first one over here. I made a little checklist of things that you always go through when doing the pattern. So remember to check the corners and sharp edges. So these are different things. Sharp edges, okay, they're different. They're similar. Straight faces, section thickness, dimensional tolerance, as well as machining allowance and small holes. I'll go through them in a moment. But firstly, the corners. If you have something like this is the stress concentration. It's like when you have a doorway. Have you seen like doorways always have, or oftentimes have little cracks like that? I feel like you guys are probably very familiar with stress concentrations by this point, but corners are not fun. Corners are stressful. They have stress, especially on the top parts of the casting. Just a side note, these notes are just notes I made from doing every single past paper I could find. So these are just good general rules to follow, and just memorize these little things to do, because you are limited at what you're allowed to have in your textbook in the exam. So yeah, let's see. Cope side refers to the top side. As we've seen, we have two parts. We have the drag and the cope. So especially in the cope side, just make sure that your casting's corners are rounded. Okay, so sharp corners or stress concentration, like I said, use fillets. Fillets mean rounded internal corners, and rounds mean, okay, these definitions don't really matter that much. I just want to explain what they meant. But just in short, if corner sharp, make corner round. Okay, just make it round. There must not be any sharp corners. For sharp edges, similar to sharp corners, then cause issues and use fillets. What I meant there is, for example, if you have something like that, right? Just fillet that over there. There's another one that you want to make around over there. This one doesn't matter that much, this bottom part. We're kind of concerned with the top parts. Then what we have are straight faces, draft angles, right? So we have this part again. If they're perpendicular to the parting line or split line, this split line over here, when we remove them, and say now our part is in multiple parts of the cope and drag. This is not like the video where we had where the whole thing was in the drag. I think I mentioned that video that it's preferred to have the whole thing in the drag. This is definitely not always the case. I think it differs in the exam paper. So just you're gonna have to use your discretion there. But there are at least multiple designs possible for any question. But anyway, if they are in the cope and the drag, like this, then you need to consider how easy it is to remove the pattern from the mold. And for that reason, we have draft angles. We angle it. slightly, okay? And you must indicate 1 to 2 degrees. So I think, let me just check what the old exams usually say. Yeah, so the old exams, they marked with saying 1 to 2 degree draft, but you can do anything like that. Okay, so here the final thing isn't drawn, but you can see that it says here change sharp edges with fillets, straight faces with draft. So those are important things to consider. Same is true for this part, for a different question, where they say there should be draft angles over here. That does seem to be the only defining factor here, because I think this is a mostly round part. See, there are fillets there anyway. Yeah, so in terms of sharp edges, not a big issue, but straight faces, yeah, those should definitely have the draft angles. Similarly here, for the pattern design again, we have our draft angles that are going to be 1 to 2 degrees. We have our fillets here, all fillets and rounded over there, draft angles. Not entirely sure what this was supposed to be marking. I think these were just marked for, oh, so they should just be consistent. I don't think this is showing that it's drafted. Not entirely sure what this is marking, but yes, just in general, I'm just showing you what the drafting does. Drafting meaning just angling it a little bit, as well as rounding corners like that. Especially since you can see the original design had sharp corners here, sharp, but these are facing the top. See, this isn't, so you're not going to be too worried about this one, but these ones are. That is why we round these, we round them. Okay, and this is perpendicular to the split line. It's perpendicular, 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 perpendicular. If it's perpendicular to the split line, we draft, we draft, we draft, we draft. Okay, cool. So you've got that. This next one is more of a general one, to do with section thickness. So aim for uniform section thickness throughout the casting. And this is to do with how it solidifies. So if you have a lot of, like, if there's like a riser going into like a little ball over here, a big sphere over here, and then goes to a little one over there and a smaller one over there or something, then obviously this one will take much longer to heat up. This will be quick. It's going to solidify faster. You want everything to be consistent throughout your whole part. These final notes, these 2 notes, you need to show the dimensional tolerances info, which is given at the end of the paper in tables. So you indicate that on your drawing. I see it's not always marked in every single paper, but in general, I've found that it is marked down sometimes when you don't show it. So to be safe, do this. Machining allowance, the same thing. We are going to be going through what these things mean in this whole section. I was about to say textbook section, but it's not in the textbook. But just know you should put it on there. Put it on your diagram. Okay? Machining allowance being the additional material we add to the casting that we're going to machine off later, like we saw in that video. This thing at the end, this little cube thing, was really rough. It had very rough edges, and we didn't want our original design to lose any volume at the end. So we add a little bit volume because we know we're going to be machining it off anyway. And in general, we tend to be very trigger happy with cores. You know, you just want to put a core everywhere, but just consider if there are small holes, it's better to drill it afterwards. So on your diagram, just make a little note and say, okay, this hole will be machined in afterwards, because it is less than so many millimeters. Just always demonstrate your understanding, especially for this module. Demonstrate why you're making these decisions, because this is machine design. A lot of these questions involve designing and all the design choices you make, which is a lot. And in order to communicate what those design choices were, you need to write it down. And that, I think, is the checklist that we go through for the pattern design. Just made a little quick, very rough thing just to remember. I see here that I highlighted these edges. So before, when I was unsure what they were doing, what they were pointing to, so that was over here. Yeah, it was for this question. Yeah, I think that was what it was. Because I highlighted here, I made this like a month or two ago, I highlighted here that these are also drafted. Even though they're not strictly perpendicular to the split line, it doesn't make much sense. But I think what I got this from was from that old paper memo that I just showed you, because that's the only instance where I've seen them pointing to a top surface like that. So I'm not entirely sure about that, but to be safe, I think the best thing to do is always follow the rule that if it's perpendicular to the split line, then you draft it, because this doesn't make sense to me. I wrote it down here because I saw it in a memo, but I don't think this doesn't make sense to me. This does. This makes sense. This is the way to go, I think.